The workplace must be devised to protect workers. This requires ergonomic considerations. Ergonomics is the science of designing the job, equipment, and work environment to fit the worker. Ergonomic safety is the practice of designing workplaces, tools, and tasks to fit the physical and mental capabilities of workers to reduce the risk of musculoskeletal disorders, improve overall well-being, and boost productivity. While the U.S. federal government lacks a specific, comprehensive ergonomics standard, OSHA enforces a general duty clause requiring employers to protect workers from recognized hazards, including those from poor ergonomics, leading to citations for violations. Employers must implement proactive measures like risk assessments, providing ergonomic equipment, proper workstation design, and training to prevent musculoskeletal disorders, or MSDs. Workplace ergonomic injuries are musculoskeletal disorders caused by factors like repetitive motion, poor posture, and overexertion. These injuries develop gradually and affect muscles, nerves, and joints in areas like the back, hands, wrists, and shoulders. Some common workplace ergonomic injuries include lower back pain, often caused by improper lifting, twisting, or prolonged sitting without proper support. Carpal tunnel syndrome, a condition affecting the wrist where the median nerve is compressed, leading to numbness, pain, and weakness. It's common with repetitive hand and wrist movements. Tendinitis, inflammation of the tendons, which can be caused by repetitive motions and overuse. Neck and shoulder pain frequently results from poor posture, especially when looking at a computer screen for extended periods or from repetitive overhead motions. Tennis elbow or epicondylitis, pain in the outer elbow joint caused by repetitive strain on the arm. And rotator cuff injuries, a shoulder injury that often develops from repetitive overhead movements. The causes and risk factors for these injuries can include repetitive motions, performing the same movements over and over again. Awkward postures, bending, twisting, or reaching in ways that put stress on the body. Forceful exertion, tasks that require a lot of physical strength. Poor workstation setup, uncomfortable chairs, monitors at the wrong height, or poorly positioned keyboards. And prolonged static positions, remaining in the same position for a long time. Ergonomic injury prevention starts with designing the workplace to fit the worker, not the other way around. The key principles and practices for workplace ergonomic design are: fit the job to the worker. The core principle of ergonomics is to make sure the work is suitable for the person, not the other way around. Reduce risk of injury. Ergonomics aims to eliminate or reduce hazards that can lead to musculoskeletal injuries, such as those from lifting, pushing, pulling, and repetitive motions. Improve productivity. When people are more comfortable and less stressed, they can be more productive and satisfied with their jobs. And prevent musculoskeletal disorders. By designing jobs to fit the worker, ergonomics helps prevent common injuries like strains, sprains, and other MSDs. The benefits of employing an ergonomic safety program in the workplace include reduced injuries. The primary goal is to prevent work-related musculoskeletal disorders, which are a leading cause of lost workdays. Increased productivity. Employees who are comfortable and healthy are more focused and efficient. Improved employee satisfaction. A safer and more comfortable work environment can lead to greater job satisfaction. And cost savings. By reducing injuries, companies can lower workers' compensation claims and other related costs. Workplace ergonomic injuries are extremely costly, with direct costs for musculoskeletal disorders, MSDs, estimated to be between $20 to $50 billion annually in the U.S. When workplace hazards, including ergonomic hazards, are present, controls must be put in place to mitigate the opportunity for workers to get injured. The way to do this is by applying the hierarchy of controls. The hierarchy of controls is a system that ranks methods of controlling workplace hazards from most to least effective, prioritizing eliminating the hazard at its source. The levels in the hierarchy include elimination. The most effective control, this involves completely removing the hazard from the workplace. Substitution. Replacing the hazardous equipment or process with a less hazardous alternative. Engineering controls. These are physical changes to the work environment or equipment that isolate people from hazards. They can include installing a barrier between workers and machinery or installing a man to reduce joint impact. Administrative controls. These are changes to the way people work, such as implementing new procedures, providing training, and establishing safety rules. And personal protective equipment or PPE. The last line of defense, PPE, includes items like back or wrist braces and are used to reduce exposure when other controls are not feasible or are insufficient. The higher within the hierarchy the hazard is removed or reduced, the more effective it will be in ensuring the safety of the workforce. Ergonomic workplace design involves customizing the work environment, equipment, and tasks to fit the individual worker, rather than forcing the worker to adapt to the job. Key components of workplace ergonomics include workstation design, adjusting chairs, desks, and monitors to ensure proper posture. This includes setting screen height, maintaining a neutral wrist position on a keyboard, and ensuring a chair has proper back and arm support. Tool and equipment modification. Using tools that are lightweight, fit the hand properly, and require less force. Task and process adjustment. Altering how work is done to avoid awkward movements, repetitive motions, or heavy lifting. Work environment and practices. Organizing the workspace to keep walkways clear, storing materials at appropriate heights, and encouraging regular stretching breaks. And worker training and education. Teaching employees to recognize ergonomic hazards and understand how to use equipment and adjust their environment correctly. Ergonomic office workstation design involves adjusting your chair, monitor, and desk to maintain a neutral posture that minimizes strain and reduces fatigue. Key elements include ensuring your feet are flat on the floor, your elbows are bent at a 90-degree angle with your shoulders relaxed, and your monitor is positioned at or just below eye level and about an arm's length away. Ergonomic factory workstation design involves arranging workspaces to maximize efficiency, safety, and comfort by minimizing physical strain. This includes optimizing the placement of tools and materials for easy reach, using adjustable workstations and equipment, providing proper lighting, and reducing repetitive or strenuous movements. The goal is to fit the job to the worker, not the other way around, which improves productivity and reduces the risk of injury. Ergonomic tool and equipment modification is the practice of designing, altering, or selecting tools and equipment to better fit the physical and mental capabilities of the user. The primary goal is to optimize the interaction between people and their work environment to reduce physical strain, prevent musculoskeletal disorders, and maximize productivity, comfort, and safety. Modifications can range from simple, low-cost adjustments to the integration of new, specialized equipment. Examples of modification include adjustable furniture. Using height-adjustable desks, chairs with lumbar support, and monitor stands to ensure neutral postures and proper eye-level alignment. Tool design. Utilizing hand tools with padded, contoured, or angled handles that allow the wrist to stay in a neutral position. Assistive devices. Incorporating mechanical assists like hoists, lift tables, or carts with casters to reduce the need for heavy lifting and carrying. Workstation arrangement. Positioning frequently used items and controls within easy reach to eliminate excessive leaning, twisting, or stretching. Accessories. Providing anti-fatigue mats for standing work, using hands-free headsets for phone calls, or implementing keyboard trays and wrist rests. And process changes. Implementing work practices such as regular breaks and job rotation to vary physical activity and reduce the duration of repetitive tasks. Ergonomic task and process adjustment is the practice of designing or modifying work to fit the person's capabilities and limitations, with the goal of maximizing productivity and well-being while reducing discomfort, fatigue, and the risk of injury, particularly musculoskeletal disorders. Task adjustments involve altering specific physical aspects of how a job is performed to minimize strain on the body. Key principles include maintaining neutral postures, ensuring joints are naturally aligned and muscles are not straining to hold a position, reducing excessive force and repetition, using mechanical aids for heavy lifting, minimizing the force needed to operate tools, or automating highly repetitive steps. Working in the comfort zone. Keeping frequently used items and tasks close to the body, between mid-thigh and mid-chest height to avoid awkward reaching or bending. And adjusting equipment to fit the user. Ensuring chairs, desks, monitors, and tools are adjustable to accommodate individual body dimensions. Process adjustments involve changing the way work is organized or scheduled to regulate physical exposure to risk factors without necessarily making physical changes to the equipment. Examples include varying tasks, rotating workers among different tasks to avoid long periods of one activity and allow different muscle groups to rest, providing adequate rest breaks, scheduling mini breaks or recovery time to allow the body to recuperate from static postures or strenuous activity, modifying work schedules and pace, adjusting production speeds or minimizing excessive overtime to reduce fatigue, and training and awareness. Educating employees on proper body mechanics, safe lifting techniques, and how to use their adjustable equipment effectively. Ergonomic work environment and practices involve designing workstations and job tasks to fit the human body to improve safety, health, and productivity. This includes adjusting your physical setup, such as your chair and monitor, and incorporating specific work habits like stretching and proper lifting techniques. A good ergonomic setup can reduce physical strain, prevent injuries, and increase job satisfaction. Ergonomic work environment factors include adjustable chair and workstations. Position the chair so feet are flat on the floor, thighs are parallel to the floor, and back is supported by the lumbar curve of the chair. Use height-adjustable work surfaces and standing mats to reduce the strain on the back and legs. Proper monitor placement. Position the monitors directly in front, about an arm's length away. The top of the screen should be at or slightly below the eye level. Layout. Arrange workstations so that lifting and twisting are minimized, and ensure there is enough space for the full range of motion. And lighting. Ensure adequate lighting to prevent eye strain. Ergonomic practices include maintain good posture. Sit up straight with your back against the chair's backrest. Keep your shoulders back and your chest out. Alternate positions. Avoid staying in the same posture for too long. Alternate between sitting and standing, and take regular breaks to stretch or walk around. Take frequent breaks. Stand up, stretch, and move around every 30 to 60 minutes to reduce fatigue. Use proper lifting techniques. When lifting heavy objects, bend at your knees, keep your back straight, and lift with your legs, not your back. And reduce repetitive motions. Vary your tasks throughout the day or use tools that reduce force and repetition to minimize strain on your hands and wrists. Lifting heavy objects can put a strain on your back and other muscles. To prevent injuries, follow these safe lifting techniques. Before lifting the object, plan the lift. Assess the weight and size of the object, and determine if help is needed. Warm up. Engage the core muscles and stretch the back and legs. And use proper footwear. Wear sturdy, non-slip shoes that provide good support. During lifting, keep back straight. Avoid bending or twisting the spine. Engage core. Tighten the abdominal muscles to support the lower back. Bend knees. Lower down to the object level. Get a good grip. Use both hands to grasp the object firmly. Lift with legs. Extend the legs and buttocks to push the object up, rather than pulling it with the back. And keep the object close to the body. Avoid extending arms or reaching too far. And after lifting, place the object carefully. Lower it down gently and avoid dropping it. Stretch and cool down. Engage in light stretching to relax the muscles and prevent stiffness. And seek help if needed. If the object is too heavy or awkward, ask for assistance from a colleague. Additional safe lifting tips include: use mechanical aids when possible, such as carts, dollies, or hoists. Break down large objects into smaller, more manageable pieces. Avoid lifting when tired or fatigued. Get regular exercise to strengthen the back and core muscles. And if back pain is experienced, a healthcare professional should be consulted promptly. Ergonomic safety considerations are crucial to an effective workplace safety program. Designing workplaces, tools, and tasks to fit the physical and mental capabilities of workers will reduce workplace injuries. We hope you found this training valuable. Please click the subscribe button so you can access additional food shore training videos.